Modeling is a process that uses math to represent, analyze, make predictions, or otherwise provide insight into real-world phenomena. When the bulk of the work is done and you've developed a solution, it's time to assess the quality of your model.
The goal of analyzing a model is to hopefully come up with a model that's most accurate and something that we can be proud of and even help people.
You don't know your model works until you begin plugging numbers in and checking if the theoretical value is actually practically what the answer is.
During the analysis and assessment phase, one of the most important things to ask yourself is, does the model make sense? Is the answer reasonable?
We had to do a lot of testing, so we took our 3 examples and we took the data for each example and we plugged it into the equation, and then we made sure that our answers made sense. So for instance, you wouldn't want to have a million of something, you should have about 100 of. Then we pretty much laid out in a table all of our different answers, compared them to each other. The bigger example is going to have a bigger answer, and we did run into that problem where the model didn't always work, so we had to go back and adjust our math. But after just a whole bunch of testing, we found models that worked pretty well for us.
Next, ask yourself, does the model behave as expected?
We kind of went through each step, and once we finished one step, we went back to make sure that it was proved.
Make sure to validate your model.
You prove it using historical data mainly because you don't know what's going to happen in the future, so you need to use historical data.
Analysis is critical in determining whether or not your model works. Ask yourself, is the magnitude of the answer reasonable? Does the model behave as expected? And can you validate the model? Here are more tips to make the job easier. You'll find these hints particularly useful when reporting your results. Be sure to leave enough time to analyze your results. Examine the outputs of your model. Does your solution provide an answer to the question you posed earlier? If it doesn't, you may need to reevaluate your problem statement. List all of your model's strengths and weaknesses. Determine your model's sensitivity to parameters and assumptions. That is, do small changes in a parameter lead to significant changes in output? Include specific improvements you might make if you had more time. This shows you are thinking beyond your first or most developed approach. Remember, you are the architect of your model. By understanding its strengths and limitations, you're one step closer to changing the world. For more information on mathematical modeling, log on to m3challenge.siam.org.